Hello friends, very good morning. And myself Dr. M.H. Annaya. And in today's video, we are going to work out a problem on a square pyramid which is cut by a section plane which is normal to HP and inclined to VP. And let us see the question for today's session. The question runs like this. A square pyramid of side of base 30 mm and axis 60 mm long is resting on HP on its base with two of its base edges equally inclined to VP. That is how the pyramid is resting on HP. So we have to write the top and front views of the pyramid to the given condition. Here you can see in the question, the two of the base edges are equally inclined to VP. So let us write down the top view, a square with the diagonals joined meeting at point O the vertex, and the front view a triangle. So friends, here I am going to mark a square of 30 millimeter side like this, and we will name this as ABCD, A, B, C and D. And here friends, we are going to join these diagonally opposite corners, and this meet at O, the vertex of the solid. And friends, let us obtain for this position of the pyramid. How does it look in the front view? So I will just draw projectors from all these points A, B, C, D, etc. and obtain the corresponding front view for these four corners, namely A dash. This is B and D, B dash, D dash. This is C dash. So friends, the height of the pyramid is given to be 60 millimeter. So from this line, I extend this line and write down a height equal to 60 mm. This is 60 millimeter, the height of the pyramid. And I mark this as O dash. O dash represents the vertex of the pyramid, and all the corners of the base are to be joined to this vertex. So I will join O dash to A dash, O dash to C dash, O dash to B dash, and O dash to D dash. So these are all the four corners of the base, A dash, B dash, C dash, D dash. So you remember this axis is perpendicular to HP, and we'll call this point as O1 dash. So O dash, O1 dash is the axis of the pyramid. Now we have drawn the position of the pyramid resting on HP, and here these two edges, namely AB and BC, make equal inclination with VP, that is 45 degrees, or all the four edges are equally inclined to VP. Friends, after drawing the front and top views of the pyramid, let us see how this is being cut by the section plane. He says the section plane is perpendicular to normal to HP, he says, or perpendicular to HP. Whenever the section plane is perpendicular to HP, or inclined to VP, or parallel to VP, it is seen as a line in the top view. So friends, we will draw the section plane at a distance of 45 degrees to VP while passing at a distance of 10 mm from the axis. In the top view friends, this O1 is the axis, and it has to pass through a distance of 10 millimeter from there. So I will just mark a line here parallel to this line, passing at a distance of 10 millimeter from the axis. From here to here, I take a distance of 10 mm, and this is the distance from the section plane S1 from the axis O. This is 10 mm. So I will mark it as 10 millimeter. The distance between the axis O and the section plane. This section plane is drawn at an angle of 45 degrees to VP. This inclination to VP is seen in the top view, and very obviously these two meet at 90 degree, because this is also 45, this is also 45. They are parallel lines. And now friends, let us see how to obtain the development. So for drawing the development, after the section plane cuts the solid, we have to retain a larger part of this. Larger part to say, that is, when it is cutting here, the base edges at these two points and the slant edges OC and this at this point. The larger part is this one, that is, the part retained for development is going to be joined by dark lines or visible lines. So this is how the remaining part of this solid looks after the smaller portion is removed. So this is the larger part, and we'll call this as part P, for which the development is to be drawn. So now let's move on to drawing the development. To start with, let us assume that the pyramid is not cut by any section plane, and hence we will draw the development of the lateral surface. And in this case, we are having four triangular faces on the lateral surface, and we are going to get four isosceles triangles. So how to get it? So friends, I just draw a line point here, O, and draw a line of length is equal to length of the slant edge. Which is the length of the slant edge? Friends, if you see here, OA, OB, OC and OD represents the four slant edges of the pyramid. And here OC and OA are parallel to XY, parallel to VP. And hence, if you are considering OC, this O dash C dash will give you true length. That is this length, O dash to C dash is the true length. And friends, the length I am drawing here is equal to true length. That is, draw a vertical line from O and mark a length equal to the true length obtained from the front. Now friends, now we'll draw another line having the same true length and join these together by an arc like this. So friends, here on this arc we have to mark 30 millimeter 4 times. So I'm going to mark on this arc 30 mm, an arc, again 30 millimeter, another arc 30 mm, third arc, finally 30 mm, fourth arc, the fourth arc. This is also true length. True length means this total length is true length. And let's join all this by straight line. And all these base edges are straight for pyramids, so let us join them also by straight lines, and they should be drawn thin to start with for all these lines. Now friends, let us start naming these corners of the base. How to start? Friends, you look here. None of these four slant edges, OA, OB, OC and OD, are completely removed by the section plane, and we have the choice to start the development from any one of these. Okay, it could be OB or OC or OA or OD. So let me start with this point or this edge B. So OB I will mark here. This is C, this is B, A, finally B, because the first line and the last line should have the same numbering. Now, after getting the development without the section plane, let's see where all the section plane is cutting the solid. Friends, here you can see here, this section plane S1, S1, which is at a distance of 10 millimeter from the axis, is cutting the two slant edges OB and OC on these two, and the two base edges AB and DC. Friends, we know that always the developments are drawn to the actual size or the true size. Hence, in the top view, all these dimensions are true dimension. So now I'm going to start from this base edges. The base edge AB is cut at this point. So it is on AB nearer to B. Take this measurement and mark on AB nearer to B. On AB nearer to B. So this is one point. Similarly, friend, on AB nearer to B we have marked. Similarly, on CD, the same distance. You have to mark on CD nearer to C. On CD nearer to C. We have got 2 points. Next, friends, it is cutting OB and OC. OB at this point, OC at this point. Friends, you remember or you know very well, these two will have the same measurement. And this point is on OC. So we will transfer that point to the O dash C dash. So maybe somewhere here. So this is the point where OC is being cut. So this is the point is to be located on OC or O dash C dash. Friends, O dash C dash is the true length line, and whatever the measurement you get here is a true measurement. So friends, on OC in the development, I am going to take this measurement and mark on OC. That is another point you get. Friends, similarly, on OB, the slant edge, you are going to have the same measurement. On OB, same measurement, because there is also true length only. So friends, I will just mark it on OB. OB, yeah, the same distance I have to mark. This is OB. Again on OB here, you have to mark the measurement. Friends, here we have got 2 points on the slant edge, OB and OC. OB I have marked, OC I have marked, OB I have marked. On the base edges, you have the 2 points, one on CD, one on AB. AB nearer to B, AB nearer to B. We have this point. And here on DC nearer to C, DC nearer to C. We have got these points now, friends. We have to join all these points by straight edges. So, friends, I will start like this. I will join these 2 points, this point, then we have this point. Again, here on this portion of the base edges is retained, and here we have to darken these. Friends, let us join all these slant edges in the development. And friends, this is how the development looks for this larger part P of the pyramid. So friends, you can number them also if you want. This is 1, 2, 3. This point is 4. And this point is 1. 1 on OB, that should be a common point. Friends, you can see after getting the development of the pyramid, one has to verify whether the solution for the development we have got is correct or not. How to verify? It is very simple, friends. You can see in the portion that is written for the development, OA should be full line, OB, full line, OD and OA, OD, OA, and the base edge rocket. OD and OA, OD and OA should full line. OD is a full line, OA is a full line. And here, on the base edges, you can see here, the part from here to here is removed on DC. That C doesn't exist. So you can see here, this portion is not there, and portion from there is also not existing. So, friends, if you see the development shown in this color line O14, A, B, 3, 2, 1, 0 represents the development of P, that's the development of the larger part of this pyramid when it is cut by a section plane at an angle of 45 degrees to VP. Friends, I hope the presentation was interesting, and if you find this useful to you, do subscribe to my channel and have a wonderful day.